Okay, you have your day 15 homework. We're actually going to do some notes and treat this almost like a note sheet, and then we'll finish it up tomorrow in class so that I can make sure you definitely understand it before the weekend. So what I'm going to do is I'm going to start by showing you a new function. It is the square root function. You're actually familiar with the square root function, but perhaps not graphically. So the square root function in its parent function form is just the square root of x. So I want to do a data table because the data table will basically serve as our moves. We've been graphing by moves. So now if I'm going to take the square root of a number, it needs to be either 0 or positive. And I'm going to choose x values that are perfect squares. So I have a 0, I have a 1, I have a 4, I have a 9, and that should give me enough. So the square root of 0 is 0. The square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So the parent function graph will start at 0, 0 at the origin. We'll translate this just like we have our others as well. But my moves will be 1 to the right will yield 1 up. And then I have to go 4 to the right, and I'll go 2 up. And usually that's about as far as I go, because you have to go all the way 9 to the right to go up by 3. So that is the general shape of this graph. So the moves are 1 to the right, 1 up, 4 to the right, 2 up, because you're taking the square root of 4. 9 to the right is 3 up. So this is our parent function. Now, I want to show you, this can be written just like we did on the board yesterday with all of the other functions we've learned. You can have an A out front, and that's, of course, will reflect it, stretch, or compress it. And then you have x minus h plus k, where your translation point is hk. And in this case, it actually is a vertex because it will be your minimum point on the graph or your maximum point, that kind of thing. So this is the same exact thing we've learned for all of our other functions. We're going to apply it here. So let's do number 1 together. The very first thing I want to look at is how is this translated. So it will be 4 to the left and down by 3. So I'm going to write -4, -3 right here. And I'm going to sketch it. There's no stretching or compressing because A is 1 and it's positive. It's just going to be the normal moves. So I'm going to go to -4, -3. I'm going to go 1 to the right, 1 up. 4 to the right, 2 up, and that's going to give me my general shape of the graph. So that's how you're going to graph these. Okay? Now the domain on these is a little bit different than some of our other functions. The domain is going to be just this -4, so see the x of -4, and then to the right. So it's going to be -4 to infinity, and it will include the -4, so use the bracket. And the range is the lowest value here. So if you think about this, the translation point, move 4 to the left, so that's my lowest x value, and then it moved down by 3, so that's going to be a -3 for the lowest y value. So the graph will go up from -3 upward to infinity. So that's a little different. It's kind of interesting. So max or min, and I definitely have a minimum at -4, -3. Where is it increasing? Well, this particular function increases always, but it's only for x's that fit in the domain, so you have to be careful with that. So I'm going to write my x values for which my y's are increasing are going to be from -4 to infinity. And remember, increasing and decreasing use parentheses. Where is it decreasing? Never. Okay, the x-intercept, we do not know. So we're going to have to solve for that. Or if I went 9 to the right, I'd go up 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. It actually crosses right there. So we don't have to solve for anything on this one. So the x-intercept, 1, 2, 3, 4, 5, is at 5, 0. The y-intercept we can see here is when we went 4 to the right, we went up 2, so it's 0, -1. Okay, the end behavior on this is also a little interesting because it only has one tail, if you will. So it goes to the right. So as x goes to -infinity, f of x is just going to, basically it's your y here, is going to -3. And then as x goes to positive infinity, it's going to go up because it's going upward, upward, upward forever. Now, where is the graph greater than 0? Well, it crosses the x-axis at 5, and then beyond that it would be above. So it's going to be 5 to infinity, it's greater than. And then where is it below? Well, it's below anywhere from the -4 to this 5. So -4 to 5. And I'll use parentheses here. So that is a new function, and it has some interesting like consequences because it's only like almost like half the function. It is the entire square root function. And the reason that that is the case is because you can't take the square root of negatives. So it kind of looks like half a graph, but it is the entire square root function. Okay, the next graph is on the back, so I'm going to do one of these with you. And it is the cube root function. So I'll start by doing a data table for this. And let me just kind of show you quickly. You can still have the same for the cube root x minus h plus k with my translation point at h comma k. So that still applies just like always. And then what does the cube root function look like? So basically the parent function is when you take the cube root of x. So I'm going to use perfect cubes this time. So this time I can use negatives because I can take the cube root of -8, -1, 0, 1, and 8. Those are all perfect cubes. The cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. Then 1 and 2. And that probably makes sense to you. So to sketch this, I'm going to go 8 to the left and down 2. I kind of ran out of room there. So be right about there. 1 to the left is down 1. I'm at 0. 1 to the right is up 1. 8 to the right is up 2. So roughly over here. I just want to show you the general shape. That is what it looks like. It's almost like a stretched out S, if you will. So that is our other new function. Now, so let's do one of these. Let's do number 1 on the back. So I'm going to start by looking at my translation point. It's -4, -1. And again, this is not actually a max or a min. It's not a vertex. So -4, -1 is where it's translated. So let's move it there. And it's not stretched or compressed or reflected at all because A is 1. So I know I can just do my normal moves, which means 1 to the right, 1 up. If I go 8 to the right, I would go 2 up. So 1, 2, 3, 4. I'd end up right here, looking something like that. 1 to the left, 1 down. 8 to the left, 2 down. So it's going to be somewhere over here. Ish. It's just approximate because you're off the graph. But this would be generally what it would look like. Okay, the domain on these is easy. It's everything. Because it goes to the left, it goes to the right. The range, same thing. It goes up to the right in the parent function and down to the left. It's increasing over the entire x values. This particular function, because it's just a parent function, is never decreasing. The x-intercept in this case we found, it is -3, 0. The y-intercept, we're going to have to plug in a 0 for x. So let's do that. We're going to plug in a 0 for x. So 0 plus 4 minus 1. Now, I'm going to be taking the cube root of 4, which I really can't do anything with. I'm going to leave it just like that. It looks weird, but that's how we do it. So my x is a 0, and my y would be the cube root of 4 minus 1. Make sure this is outside the radical sign. Okay, now, as x goes to negative infinity, your y's are going down. As x goes to the right, your y's are going up. Where is it greater than 0? Well, it crosses at -3. So -3 to infinity, it's greater than 0. And then it's less than 0 everywhere else. So negative infinity up to -3. Is this an even, odd, or neither? This is a neither because it was shifted away from the origin. All right, so that is basically what the lesson will be tomorrow, or for tomorrow. And I want you to go ahead and try number 4 on the front. This is what I'm going to be checking. Number 4 on the front. And then I also want you to do number 4 on the back. And then I'll check that tomorrow, see where your questions are, and then we'll finish up the worksheet in class. And y'all have a great day.